Have you ever faced a situation when your trained machine learning model, which was giving 95% accuracy in your notebook, failed in the real world? It started giving you garbage predictions after deployment. Well, if the answer is yes, then don't worry. You are not alone. Over 85% of machine learning models never make it to production or fail shortly after deployment. In today's video, we will explore the top reasons why ML models fail in production and how MLOps help solve them. Let's jump in. First, and probably the most common reason, is data drift. This happens when the input data your model sees in the real world is different from the training data. For example, let's say we have this fraud detection model which is trained on last year's data, like with standard transactions, no holiday rush, and no fancy app features. So the model worked great, giving you accurate predictions. But now in production, it's the festive season. People are shopping differently, bigger orders, new payment options, huge discounts, and maybe using new features on your app. So using this same model over this data is now giving you the wrong predictions. So what happened here? So here the input pattern actually changed. So this is called data drift, and your model start giving wrong result not because it is bad, but because the data it is seeing now has drifted away from what it had learned on. So always monitor your data in production. Data drift is silent, but it can crash your ML pipeline if you are not watching. Next reason is concept drift. This is when the relationship between input and output changes over the time. So to understand this, let's take an example. So let's say we have a model which predicts the prices of the houses. So it was trained on, let's say, on year 2022 when the economy was stable. So at that point of time, a house of size of 2000 square feet, which is, let's say, located in a suburban location. So at that point of time, the model was predicting the price of this house as 80 lakhs. But now, let's say it's year 2025, and like the economy has crashed down, or maybe a new tax policy has been implemented. So due to that, for the same input, like for the same size of the house, for the same location, now the model is still predicting the price as 80 lakhs, but in actual actual price is actually 55 lakhs. So here you can see that the input is same, but the output logic changed due to external factors, and due to which the model fails. So the concept drift here means that the mapping of your model is on which the model has learned on is no longer valid, and unless you retrain it, it will silently make wrong predictions. Next reason is no monitoring. So let's say you have launched a model having a very good accuracy and a good user feedback. As weeks go by, the model slowly starts degrading. It may be due to data drift, concept drift, or unseen inputs. And the worst part is there is no alert system or any monitoring setup. No one even realizes that the model is misbehaving. So, without monitoring, your model can quietly break, and you will only notice it when the business impact becomes too big. Fourth reason is poor versioning. To understand this, let's say we have five models generated having different accuracies. Now for each of these models, since you have not versioned it, so you won't be knowing it, like on which data set or which script or which configuration was actually used to train these models. So now let's say if any of this model is now deployed to production and you have encountered a bug over there. Now, while trying to debug it, how will you know to which data set or script or configuration you have to see to troubleshoot this? So that's why we need version control, and that too not just for the code but for the data, your models, and the configurations as well. As versioning all of them will eventually help you get reproducible pipelines, easy rollback, and faster debugging. Fifth reason is lack of proper testing. ML models are not just traditional softwares, they actually make decisions. So, if you are not testing for bias, fairness, or robustness, you are actually shipping unpredictable models. To understand this, let's take a simple face recognition model. So, this face recognition model is trained on a specific demographic data. So, due to that, it will work well on one demographic but will fail on others. So, here as you can see, the bias in the training data actually resulted the bias in prediction as well, making the model unfair and unpredictable. Sixth reason is team misalignment. So data scientist trains the model and DevOps team deploys it. So let's say the data scientist has trained the model in his Jupyter notebook only, which works well on the local data, and he is using the Python version of 3.10, pandas for v2.0, and other versions for different packages, and his APIs are is actually returning JSON format. But now the DevOps team thinks that this model is actually working on different environment. Let's say they are trying to deploy the same model on Python version 3.8, different version for pandas and other packages, and they are expecting the API to return as XML response, and there are much more missing dependencies. So if the handoff from data scientist to DevOps teams is broken, then the whole model will collapse in production. Seventh reason is low feedback loop. So some systems take weeks or months to collect user feedback. So if your model is wrong but you don't know it quickly, it will continue to perform poorly. So to understand this, let's take an example of a medical diagnosis model. So here, after the user has provided an input, let's say the model predicted it as a flu and user has also seen the results. But after the lab testing, it came up that it is COVID, and the lab test came after 30 days. So, after this, the feedback was collected and the model is retrained. But here, as you can see, that the delay in knowing the mistakes actually predicted in wrong predictions. Next is deployment gaps. Your model may shine in your notebook, but production is a different thing. If your environment isn't identical, the model could break instantly. It could be due to missing libraries, wrong environments, or no containerization. That's why tools like Docker, FastAPI, and versioning are lifesavers here. They help you bridge the gap between experimentation and deployment. So these are the top reasons ML models fail in the real world. But the good news is following the MLOps practices like versioning, monitoring, testing, automation, and collaboration can help solve all of these problems step by step.